Hi, this is James Garden, the CineTechGeek, and I'm here at Flanders with Bram, the pretty much the chief monitor man here. He knows all about the colour science and how these monitors work. So he's the man to talk to when you really want to see what's going on with grade 1 monitors in the world today. So I've trapped him in the little corner here in front of some of the new monitors that they're displaying today. So just quickly though, firstly I'd like to go over what are you announcing this year and tell us what's happening with Flanders.
Sure, so the biggest announcements for us are, this is the first time we're showing our new XM311K, which is a 1000 nit capable HDR monitor. It's a Dolby Vision mastering level monitor. And one of the exciting things with that is it wasn't here at the last NAB. We started shipping it late last year, but we've just announced a price drop on it. So now we're trying to make it a little bit more accessible. They're still quite expensive to make, but it's a $35,000 monitor now instead of a $45,000 monitor.
Wow.
Hopefully that helps some people who are trying to get into HDR and trying to justify the costs. We also have, first time at NAB, that we're showing the XM551U UHD OLED monitor and the XM651U, it's big brother, 65-inch UHD OLED monitor. Not mastering level HDR monitors, but certainly capable of HDR in more basic HDR monitoring type applications, QC, client monitoring, things where you're not held to those very high kind of Dolby Vision mastering type standards. And then the last big announcement for the show was we now do tetrahedral LUT interpolation on our Box I/O devices. We've rolled that out on our XM series monitors as well, which just provides a better level of quality with the same exact lookup tables.
Fantastic, and that's very interesting if you're into LUTs. I hope you're going to study the tetrahedral stuff. I was just given a quick, super fast training session by Bram, and it does make a big difference, especially on set if you're doing any sort of LUT and on-set grading. So, yeah. Very important. But so you were telling us, or we were talking before about there's been certain technologies coming out for HDR.
Yep.
And some technologies are better for one thing to another thing. And what trends do you see going forward with the capabilities and the type of HDR grade 1 monitors that are going to come in the future?
Yeah, absolutely. So there are definitely different solutions available to be able to address different needs, right? And so, for example, we make an XM310K, which is our 3000 nit HDR monitor. We make a XM311K, which is our 1000 nit monitor. People ask us all the time, which one's better? Well, if one was clearly better, I'd probably only make the one because they're quite expensive to make, and it does kind of make for some confusion because people now have a harder decision to make. The reason we do this though is because they really do address these different needs. If you need over 1000 nit HDR mastering, and some facilities are starting to ask for this, there's not a lot of ways to approach that these days. Really the only way to approach this in a successful way is to use a zoned backlight system, which is what the 310K uses. So it uses an array of over 2,000 LEDs that can get very, very bright, and then a standard essentially IPS LCD panel up front. You do 3,000 nits peak luminance on it. It's one of the brightest commercially available professional HDR monitors out there. But with any zoned backlight, you can always throw some type of material at it that will break the zoned backlight algorithms because you have less zones than you have pixels. Yeah. So if you have very, very small bright objects, you have to decide how you deal with those. Do you dim those to prevent artifacts? Do you allow for halation and flare? So we have like 4 different modes you can put the monitor in. In 99% of content, you can leave it in the kind of default mode and it will look pleasing. But when you get to those challenging scenes, the operator has to decide what do they want to see, what artifact are they going to accept, the halation and the flare, the dimming of the peak, and so you have those toggles. If you don't need to do over 1,000 nits, you probably don't want to hassle with those things. And a lot of people are just delivering, P3, D65, or Rec 2020, D65, SC2084, HLG. And for that, you can use something like the XM311K, which uses a technology called light modulating cell layer, and that is basically not going to present any artifacts for you. There are some challenges with this technology, but the beautiful thing about it is you get OLED level blacks, no burn-in because it's not an organic compound OLED, and you have the ability to do 1,000 nits full screen. There's no loading behavior whatsoever. And the way that light modulating cell layer works is you have a backlight that's on at full blast at all times. You have a panel up front that's red, green, and blue filters, and then you have a panel layer in between that the best way to think about it is kind of like a monochromatic LCD. So it just modulates the amount of light getting to that front panel, but it doesn't have any sort of color filters associated with it. And you get a multiplying effect there, so you get a 1,000,000-to-1 contrast on that. So very interesting technology, but there are challenges. Transmission efficiency is very low going through that. So what that means is that
very bright light.
It's a very bright light, it's drawing a lot of power, and it's kicking off a lot of heat. It's actually the first monitor we've ever built that has fans built in, and we had to do that because it does generate so much
It sounds
heat.
a little bit like the Dolby Gold monitor, or whatever it is. Is it a similar technology or similar implementation?
The Pulsar is more similar to the 310K with the zone backlight. The light modulating cell layer is a technology that you're seeing in a few different monitors now. There's the ISO, the Sony, ours are all using some variation of this light modulating cell layer technology. This is not what a manufacturer wants to promote for their brand, but this is, in essence, a stopgap thing because the transmission efficiency is so low and because power consumption is so high, and there are other challenges with it, like your viewing angles tend to be a little bit narrower than something like the zone backlight because you are going through 2 layers of panel, of course. It's a great solution for the here and now. I don't think it's really scalable in the long term, 10, 15 years out for the consumer world, because no one wants to hang these thick monitors that draw so much power and generate so much heat on their, above their mantle in their living room or anything like this. So it's the only way to really do this kind of perfectly now. In the future, though, I think we'll move to more direct view technologies that don't have the problem of OLED. So the thing on the horizon I think everybody's really excited about is micro LED.
Yeah.
But micro LED is not a here and now thing at this size at a reasonable price. You see these giant cinema-sized walls that are using a technology like this, and that does work well if you have the money for it.
Right.
But the technology really needs to progress a lot. So we're providing the here and now solutions. We think they do a great job, but I'm not going to be that salesperson or whatever that tells you that this is the future of display technology for the next 20 years, because it's not. I honestly don't feel it will be.
But it's the best for now.
It's the best for now. It's what you can get. It's a bit like back in the day we had CRTs, and people were reluctant to look at other technologies, but as great as they were, they had lots of problems too, and eventually something better came along, and something better will always come along, and I strongly feel that way about this technology as well. But for people who need to get the job done today, for those paying projects, this is the best solution.
Okay, anyway, thanks. We're going to do another video on some topics which is more accessible to the rest of the industry, but we'll go into a next video to do that. But bye for now for CineTechGeek at NAB 2019.